Testing, testing. Hi, hi. I'm back. Good morning or evening or noon. Good noon. Nope, it's good afternoon. Yay, I'm so excited that today. Oh, yeah, I should definitely start sharing my screen. We finished the courses that I was working on, and today I was like, I need to wear something special because we're starting something new. And do not focus on the fact that my hand looks like it's in my skirt. That's by design, obviously. Yes, today we are starting the we're starting here, and if all goes well, I may do something else in the stream. But I am doing based on the title, what I wrote on the title. So HuggingFace has a lot of courses right now. LLMs and NLP is like it's the hot thing. So that's where I want to start. I'd like to think I have some background in ML/NLP, but it's ever changing. Sure, it's good to have a base, and that's why I took the other course, which is the backlog is on YouTube if anyone's interested. Sorry, I did Fast AI's Introduction to Machine Learning for Coders to give myself a good foundation. I will say that I wasn't the best student because I was not. I I don't know. I didn't feel like I was doing assignments or anything. So that's where I am. Today is the NLP course for by Hugging Face. I also am interested in this Carnegie Mellon University lecture course. I think it'd be useful, like even about background and more theoretical side of NLP, because I'm guessing this will be very practical. And like something I noticed yesterday is that we're starting with transformers because that's what everyone is using. But here, transformers don't come until lecture 5 because it's a course, and in a university course you have to start like from the beginning. All right, so I am going to watch this introduction video, but I'll probably need to check the setup first. And yeah, that's cool. Let's go dark mode. Um, I'm gonna dismiss this message, but I thank you for your point. Okay. Oh, all right. I noticed that yesterday my voice was really low. The only reason I didn't actually check any settings, let's be honest, is that I have a low voice when I'm speaking. So apologies for that. I will not be yelling, but I will make sure that all sound that you are hearing is uniform, because that's useful. And yes, flowers are coming out of my face. Thanks for noticing. Okay. I will make everything 1.25 because like my patience is, it should be even higher, but it's fine.
Welcome to the Hugging Face course.
Hi.
This course has been designed to teach you all about the Hugging Face ecosystem, how to
Okay.
use the dataset on Model Hub, as well as all our open source libraries. Here is the table of contents. As you can see, it's divided in 3 sections, which become progressively more advanced.
Okay.
At this stage, the first 2 sections have been released. The first will teach you the basics of how to use.
I'm guessing everything is released. Hold up. Main. Oh, you're right. Wait, no. Ah, are they continuously Huh. Very interesting. Main NLP tasks and how to ask for help, which is this part, and then building and sharing demo, which is this part contributing to Hugging Face? Okay.
Use the transformer model, fine-tune it on your own dataset, and share the result with the community.
Okay.
The second, we'll dive deeper into our libraries and teach you how to tackle any NLP task. We're actively working on the last one and hope to have it ready for you for the spring of 2022. The first chapter requires no technical knowledge and is a good introduction to
Hold up. Spring of 2022? When is this
learn what
from?
transformers model can do and
2
how
years ago. Huh. He said, oh, let me go back a bit. Is it?
spring of 2022.
Huh.
The first chapter requires no technical knowledge and is a good introduction to learn what transformers model can do and how they could be of use to you or your company. The next chapters require a good knowledge of Python and some basic knowledge of machine learning and deep learning.
Okay.
If you don't know what a training and validation set are or what gradient descent means, you should look at an introductory course such as the ones published by deeplearning.ai or fast.ai. It's also best if you have some basic.
I did that, and I actually saw it in the required part. Here, see? But it's deep learning for coders. I did the intro to ML.
Physics in one deep learning framework, PyTorch or TensorFlow. Each part of the material introduced in this course has a version in both those frameworks, so you'll be able to pick the one you are most comfortable with. This is the team that developed this course. I'll now let each of the speakers introduce themselves briefly.
Hi, my name is Matthew and I'm a machine learning engineer at HuggingFace. I work on the open source team and I'm responsible for maintaining particularly the TensorFlow code there. Previously, I was a machine learning engineer at Parsley, who have recently been acquired by Automatic, and I was a postdoctoral researcher before that at Trinity College Dublin in Ireland, working on computational genetics and retinal disease.
I was like, I don't know where to put this accent. Dublin, Ireland. Okay. I don't know why I thought Scottish. Sorry if that's not. Okay.
Hi, I'm Lysander. I'm a machine learning engineer at Hugging Face, and I'm specifically part of the open source team. I've been at Hugging Face for a few years now, and alongside my team members, I've been working on most of the tools that you'll get to see in this course.
Hi, I'm Sylvain. I'm a research engineer at Hugging Face and one of the main maintainers of the Transformers library. Previously, I worked at fast.ai, where I helped develop the fast.ai library as well as the online book.
No way!
Before that, I was a math and computer science teacher in France.
Oh, that's cool.
Hi, my name is Sasha and I'm a researcher at Hugging Face, working on the ethical, environmental, and social impacts of machine learning models. Previously, I was a postdoctoral researcher at MILA, University of Montreal, and I also worked as an applied AI researcher for the United Nations Global Pulse. I've been involved in projects such as Code Carbon and the Machine Learning Impacts Calculator to measure the carbon footprint of machine learning.
That's so cool.
Hi, I'm Merve, and I'm a developer advocate at Hugging Face. Previously, I was working as a machine learning engineer, building NLP tools and chatbots. Currently, I'm working to improve the hub and democratize machine learning.
Hello everyone, my name is Lucille and I'm a machine learning engineer at Hugging Face. To tell you in 2 sentences who I am, I work on the development and support of open source tools, and I also participate in several research projects in the field of natural language processing.
G'day there, I'm Lewis, and I'm a machine learning engineer in the open source team at Hugging Face. I'm passionate about developing tools for the NLP community, and you'll see me at many of Hugging Face's outreach activities. Before joining Hugging Face, I spent several years developing machine learning applications for startups and enterprises in the domains of NLP, topological data analysis, and time series. In a former life, I was a theoretical physicist, where I researched particle collisions at the Large Hadron Collider in CERN.
No way.
Hey, I'm Leandro, and I'm a machine learning engineer in the open source team at Hugging Face. Before joining Hugging Face, I worked as a data scientist in Switzerland and have taught data science at university.
That was cool. That was an intro to the people. All right, I think we went through these. Yep, we did. Frequently asked questions. Is there a certificate? Not this one. Oh, how should I take this course? Designed to be completed in a week, each chapter. So 1 to 9, fair. Wait, this is a chapter? Yep. Okay. I'm not gonna underestimate it, because last time I was like, 8 weeks, I'm gonna finish this in like a few weeks, and then I didn't. So it probably took me 8 months last time. So I'm not gonna be cocky and say just this in 1 week. No, I'm not gonna do that. With approximately 6 to 8 hours of work per week. How long would that take me? Like 3 streams, I hope. You can take as much time. Thank you. Where can I ask questions? There are forums. Yeah, I saw this yellow thing right here. Coolsies. What else? Code. Code and Code Lab. Studio Lab? What is that? Okay. Amazon. The Jupyter notebook containing all the code from the course are hosted on the here? Oh, GitHub. Okay. If I want to do them locally. Okay, thank you. How does one contribute to the course? Bug typo. Yeah, I like doing that. Oh, so this course is translated. Really? How can I change the language? I mean, not that I'm planning to. I'm just curious. No way, it's in Arabic. Yeah. Okay. What's BN? That's Deutsch, English, Espanol, Hindi, Korean? No way! I'm just curious. Still English?
Welcome to the HuggingFace.
Sorry. I don't know why I thought the video would be in Korean. Okay. Yeah, that's pretty cool. I'm gonna go back to English. That's it. What else is there? Translations. This is for reuse. Alright. In this chapter, we'll learn how to use the pipeline function to solve NLP tasks such as text generation and classification. So we're just jumping into it. About the transformer architecture. Okay. I'd like to learn more about it. How to distinguish between encoder, decoder, an encoder only architecture, a decoder only architecture, and an encoder decoder architecture, and their use cases. Looking forward to it. Before jumping into transformer models, let's do a quick overview of, a good an intro. Natural language processing is and why we care about it. What is NLP? NLP is a field. Should I zoom in? I feel like this deserves a zoom in. But if I do that, then you can't see it. I think that's good. Yes. NLP is a field of linguistics and machine learning focused on understanding everything related to human language. The aim of NLP tasks is not only to understand single words individually, but to be able to understand the context of those words. Yes. The following is a common list of NLP tasks with some examples of each. Classifying whole sentences. Or just classification, right? No? Okay, we have getting the sentiment of a review. Detecting, okay, yeah, that is classification. If an email is spam, determining if a sentence is grammatically correct, or whether two sentences are... Wait, spell checking is classification, huh? That's cool. Two sentences are logically related or not. That I don't know. It's our IRL use case. There we go. Classifying each word in a sentence. Identifying the post tagging, right? Part of speech tagging. Identifying the grammatical components of a sentence, noun, verb, adjective, or the named entities. Yep. Person, location, organization. Generating. Oh, sorry about that. Generating text content. What is it called? Something gen. Text generation, right? Text gen. Okay. Completing a prompt with auto-generated text, filling in blanks in a text with masked words. Okay. Extracting an answer from a text. Question and answering. Giving a question and a context, extracting the answer to the question based on the information provided in the context. Generating a new sentence from... Whoa! Translation and summarization. Okay. I thought this would be just normal text generation, but no. New thing. Okay. NLP isn't limited to written text though. True. That's true. Audio and vision. Speech recognition and computer vision, such as generating a transcript of an audio sample or description of an image. Yes, we know about ImageNet. So, yeah. Is my wing blocking the text? What a question to ask. Why is it challenging? Good question, because humans are unpredictable. Computers don't process information the same way as humans. For example, when we read the sentence, I'm hungry, we can easily understand its meaning. Similarly, two given sentences, such as I'm hungry and I'm sad, given two sentences, I'm hungry and I'm sad, I think I want to go for hangry. But no, that's hungry and sad, which doesn't have a composite word. We're able to easily determine how similar they are for machine learning models. Yeah, I mean, not similar, but okay. Such tests are more difficult. The text needs to be processed in a way that enables the model to learn from it. And because human language is complex, we need to think carefully about how this processing must be done. There has been a lot of research done on how to represent text. Yep. I guess the best way is to put it in a, like, oh, I forgot, but word embeddings. There we go. We'll look at some methods in the next chapter. Let's go. Okay. Transformers, what can they do? Ooh, we have a collab here. Let's look at transformer models. In this section, we'll look at what transformer models can do and use our first tool from the transformers library. Excuse me. Okay. The pipeline function. See that open in Colab button on the top right. Click on the notebook with all code samples of the sections. Button will be present in any section containing code examples if you want. Oh, I forgot to look at setup. But yes, if I want to run things locally, I will probably need to check setup, which I might, but not right now. Let's open in Colab. Okay. It's already written. I'll probably need to do copy to my own drive to be able to make changes and add notes. Transformers are everywhere. Transformer models are used to solve all kind of NLP tasks like the ones mentioned, yep. Here are some of the companies and organizations using Hugging Face and Transformer models. I mean, everybody's publishing stuff on Hugging Face, that's true, but cool. Who also contribute back to the community by sharing? Yeah, that's true. That's really cool. Allen Institute, Facebook AI, Microsoft. Grammarly has one model. Google has the most. Oof. Typeform? That is surprising. I don't know this one and I don't know this one, but still, pretty cool stuff. The Transformer library provides the functionality to create and use those shared models. The Model Hub, contains thousands of pre-trained, definitely thousands. Look, this is thousands. This is 600,000 models. Pre-trained models that anyone can download and use. You can also upload your own to the hub. Hugging Face is not limited to, obviously. Anyone can share any model or data set they want. Before diving into how transformer models work under the hood, let's look at a few examples of how they can be used to solve some interesting NLP problems. Okay. Let's go. Pipeline function.
The pipeline function. The pipeline function is the most high-level API of the Transformers library. It regroups together all the steps to go from raw text to usable predictions.
Okay.
The model used is at the core of the pipeline, but the pipeline also includes all the necessary pre-processing, since the model does not expect text but number, as well as some post-processing to make the output of the model human-readable. Let's look at the first example with the sentiment analysis pipeline.
Okay.
This pipeline performs text classification on a given input and determines if it's positive or negative. Here, it attributed the positive label on the given text.
Wait. You just put sentiment analysis in there? How?
With a confidence of 95%. You can pass multiple texts to the same pipeline, which will be processed and passed through the model together as a batch. The output is a list of individual results in the same order as the input text. Here, we find the same label and score for the first text, and the second text is judged negative with a confidence of 90%.
This one is hard to figure out that it's positive, like for a model probably. Because weighting can be negative.
99.9%. The zero-shot classification pipeline is a more general text classification pipeline. It allows you to provide the labels you want. Here, we want to classify our input text along the labels education, politics, and business. The pipeline successfully recognizes...
Wait, are these categorizations of the hub? Like, because I know these categories exist, and zero shot. Where's NLP? Where's the analysis one? Classification. Yep. What was the other one? Sentiment analysis? I don't know. Still.
It's more about education than the other labels.
So we ask for a category and it gives us what it thinks is the best for an end-to-end style?
Of 84%. Moving on to other tasks, the text generation pipeline will autocomplete a given prompt. The output is generated with a bit of randomness, so it changes each time you call the generator object on a given prompt. Up until now, we've used the pipeline API with a default model associated to each task, but you can use it with any model that has been pre-trained or fine-tuned in this task. Going on the model hub, HuggingFace.co/models, you can filter the available models by task. The default model used in our previous example was GPT-2, but there are many more models available, and not just in English. Let's go back to the text generation pipeline and load it with another model, distilled GPT-2. This is a lighter version of GPT-2.
Ah, so task model. Okay.
Created by the HuggingFace team. When applying the pipeline to a given prompt, we can specify several arguments, such as the maximum length of the generated text or the number of sentences we want to return, since there is some randomness in the generation. Generating text by guessing the next word in a sentence was a pre-training objective of GPT-2. The fill mask pipeline is a pre-training objective of BERT, which is to guess the value of masked words. In this case, we ask the two most likely values for the missing words according to the model, and get mathematical or computational as possible answers.
Doesn't matter.
Another task Transformers model can perform is to classify each word in a sentence instead of the sentence as a whole. One example of this is named entity recognition, which is the task of identifying entities such as persons, organizations, or locations in a sentence.
That's so cool.
Here, the model correctly finds the person, Sylvain, the organization, HuggingFace, as well as the location, Brooklyn, inside the input text. The grouped entities equal true argument used is to make the pipeline group together the different words linked to the same entity, such as hugging and face here. Another task available with the pipeline API is extractive question answering. Providing a context and a question, the model will identify the span of text in the context containing the answer to the question. Getting short summaries of very long articles is also something the Transformers library can help with the summarization pipeline. Finally, the last task supported by the pipeline API is translation. Here, we use a French-English model found on the Model Hub to get the English version of our input text. Here is a brief summary of all the tasks we've looked into in this.
So that's for just usage. Like if you want your app to do something, you just call it, and that's it, it works. Are there limits?
Video. Try them out through the inference widgets in the Model Hub.
Sure. Most basic, let me zoom in a bit. Zoom. That should be seeable, okay. The most basic object in the Hugging Face Transformers library is, why do you call it basic? Oh no. Okay, I'm back. Why do you call it basic? It's useful. Connect a model with its necessary pre-processing and post-processing steps, allowing us to directly input any text and an intelligible answer. So I'm gonna copy this to Drive. Daisy, come on. Yay, okay, hi. Sure. Okay. So, what is sentence piece? Okay, yeah, thanks. Alright. So, first we're getting sentiment. Oh, okay. So I'm gonna change the text. I've been waiting for Hugging Face. How should I change it? While this is downloading. I have no idea if this is a positive or a negative thing. Let's see. It's just like a sentence. Why is it taking so long? What happened? Oh god, that scared me. What is happening? Yeah, I know no model was a negative. I'm sleepy is a negative word, thing, sentence. Okay. Cause like for me it doesn't feel negative. Anyway. I'm gonna just run this as it is and see if this changes because it's from 2021. Wait. Yeah, it is from 2021. So we have 95, 98, and 99, 94. Let's see. Yep, same. The level of positivity and negativity has not been updated. So everything the guy said is now down here, right? No? By default, this pipeline selects a particular pre-trained model that has been fine-tuned for sentiment analysis in English. Boo! Why is English default? She says while speaking English. The model is downloaded and cached when you create the classifier object. If you rerun the command, the cache model will be used instead. There is no need to download the model again. Good. There are 3 main steps involved when you pass some text to a pipeline. The text is pre-processed into a format the model can understand. The pre-processed input are passed to the model. The predictions of the model are post-processed so you can make sense of them. So it's a one package deal, the pipeline thing. Some of the currently available pipelines are feature extraction, fill mask, named entity recognition, question answering, sentiment analysis, summarization. That's it? I expected a bit more. Oh, where are we? Why are we here? Oh, okay. I thought that's what I was about to ask. Do we have anything for... Oh, multimodal. Whoa. Okay. Question answered. Let me leave. Zero shot classification. We'll start by tackling more challenging tasks where we need to classify texts that haven't been labeled. This is a common scenario in real world projects because annotating text usually takes time. Okay, it's time consuming and requires domain expertise. For this use case, the zero-shot classification pipeline is very powerful. It allows you to specify which labels to use for the classification so you don't have to rely on labels of the pre-trained model. Okay. You've already seen how the model can classify a sentence as negative, positive using 2 labels, but it can also classify the text using any other set of labels that one might like. Okay, so here it's using zero-shot classification, giving it this sentence and the possible labels. If we want to run it, let's update it. CL is streaming on Twitch. I'm not gonna update the candidate labels just to see what it comes up with. It's not just Twitch, by the way, it's also YouTube. Let's see what it comes up with. I don't think it's educational. Might be business. Let's see. Defaulted to bar large. What was the other one? Defaulted to distill. Okay. Distill bird. It is. Okay, it's more education. Oh my god, it's business, see? 75% business, 16% education. I'd say mine is more educational, but it's fine. You don't know me. Alright. Time. This pipeline is called Zero Shot because you don't need to fine tune the model on your database to use it. It can directly return probability scores of any list of labels you want. Probably, but anything? Let me update one of the labels to content creation. I have no idea if such a thing exists. Content creation. I doubt it will work. Let's just try. I have no faith. Huh. Okay, now I have some faith. It's not a lot. But yes, business was more correct and now content creation is more correct. You're making me have faith in you. Okay, what's next? I did play around. Text generation. Made me think of girls' generation. Okay. Let's see how to use. Now let's see how to use a pipeline to generate some text. The main idea here is that you provide a prompt and the model will autocomplete it by generating the remaining text. This is similar to the predictive text feature that is found on many phones. So text generation is like a mix of spell check, because that's what happens on the phones. Oh no. No. Yep, predictive, got it. Sorry, it's not I mean, it is autocomplete, but not for, got it. Text generation involves randomness, so it's normal if you don't get the same results. Normal. So I'm gonna run this part, but I'm gonna update it. I'm gonna say on the Twitch stream, we will teach you how. I don't know what will happen, but let's see. We are using GPT-2. Huh. Okay, that's pretty old. To make... I have no idea what this is, but okay. What is that? TCC Giant Titan? 2-in-1? Who won that? Help me. I'm gonna remove the 2-in-1. I'm gonna remove the new lines and see what this is. I have no idea. Sure. I have no idea. Alright, so apparently I'm not a real streamer. Thank you. One can control how many different sequences are generated. Num return sequences and the total length of output with the max length. Okay. Use the num return sequence and max length. 2 sentences and 15 words. I think it's already... No, it's not. Alright. Oh, it is. Okay. On the Twitch stream, CL learns about... takes a Hugging Face course on. Let's see where that takes me. Uh-oh, this is wrong. Learn takes... Oopsies. Okay, this is scary. Our team and our team. We will be discussing how to approach this game. Okay, sure. How to deal with your opponent. Spoiler. Okay, apparently everything on Twitch is games. Alright. using any model from the hub in a pipeline. The previous example used the default model for task at hand, but you can also choose a particular model from the hub to use in a pipeline for a specific task, say text generation. Go to the model hub and click on the corresponding tag on the left to display only the supported models for the task. You should get to a page like this one. I mean, I was already here, so let's do text generation. Yes, I want to use llama. Copy. 뭐야? I'm gonna add my own code then. Where's this distill part? 없는 것 같아. Okay. What I'm curious about is the difference between how good the text is, if it is this or if it's that. So let's test both. Okay. And I am going to give you my poorly worded sentence, but worded better. So that. Let's do this. You go first, and then you can go next. What? Oh, because they are named the same thing, right? No? Why? On Saturday after 2 hours of what? What? What is happening? Does anyone know what hugging face is? Happiness, sure, is an emotion, but it doesn't give the dot dot dot. Apparently no one knows what hugging face is. I'm gonna write edX next time. But I can't use the llama. How do I use it? Do I do the whole thing? Do I copy this and put it here? Okay, let's try again. Oh god. No, I'm not authorized. It's a gated repository. What do I use then? I'm gonna try this. Oh, wrong button. Eagle Quintana? Ah, okay, that's fine. Please do that. 11 billion. Oh wow, that might take a while. You can refine your search by clicking on the language tag, pick a model that will generate text in another language. Should we do that? Should we do another language? Checkpoint for multilingual models that support several languages. Widget enabling you to quickly test the model before downloading it. Use filters to find text generation for another language before to play with the widget. Coulda. I'll do that. Another language. Problem is, I don't have writing ability in many languages. I mean, I have it in Arabic, but what do I do? Am I overdoing it with the download? Should I have not used 11 billion? There's a reason they chose Distill GPT-2 because it's small, isn't it? This is multilingual, but not any language that I know besides English. How can one check for size? Oh, that's something Korean. Is it NVIDIA? No. Okay. Oh, from Yonsei. Cool. Oh, is that Son? Oh, sorry, I got distracted. Okay. Okay. Model ID. This is the model ID. Copying model ID. Yeah, no, I shouldn't choose anything that's too big. I just want to like write 안녕하세요. That's it. Trying to read something. Cool. Okay. How long do I have to wait? I chose a bad model because the size is too big. It's fine though, I hope. Should I stop? Look at these sizes, man. Okay. The inference API. All the models can be tested directly through your browser using the inference API, which is available on Hugging Face website. You can play. Are you just taking me to Hugging Face? No, like I think most of them allow you to use it directly here. This one doesn't, but like if you go to llama. Wait, where is it? Use this model? Huh. You can input in custom text and also available as a paid product. Okay, very interesting. Thank you. Mask filling, we saw that. The top K argument, which was here, doesn't it tell you how many possibilities do you want? Controls how many possibilities you want to be displayed. Note that here the model fills the special mask word, which is often referred to as a mask token. Other mask filling models might have a different mask. We should check by looking at the mask word used in the widget. Merci. Bird base case. I really should stop this, shouldn't I? Oh yeah, I definitely need to stop this. Stop. Thank you. I'm gonna choose something lighter. How can one search something light? Oh, I see something light. It's literally written light. No? What does that mean? What happened? Okay. This is extremely fun. What was the other bird thing? Bird base. Case? I have no idea if this bird... I think bird... How many birds are there? I'm searching in text generation, so... Archive, fine-tune, Wikitext. Sure, I don't know what this is. I don't know. Oh, there's an inference API. I just want to use something, and if it doesn't work, it's fine. It is somewhat working. I'm gonna take you and put you somewhere. This is fun. Yeah, it's fine. It's fine. Forget it. Forget it. Sure. So I'm gonna use the model this here, right? Should I get an error? Yes, because the mask is different. I knew it. It should be in this. Oh. Do you accept small or should I make it big? Mask. Now it should work. Yay! All about the model. Role models? Cute. Next, named entity recognition. My name's CL. I work at nowhere on Earth. Grouped entities true because to tell the pipeline to regroup together part of the sentence that correspond to the same. What do you mean? Here as a single organization, even though the name consists of Okay. See in the next chapter. Whoa. That's really cool. Sure. We can try POS. Organization. That's it? Because Earth is not an entity? How come? And POS? Yeah. Okay, part of speech tagging. No? Or is it post tagging? No? How do I find post tagging? Do I not? I work at... Okay, I'm gonna say I stream on Twitch and YouTube. There. Now, do you assume that my name is not an organization, or is my name still an organization? question answering. Does it matter if context is given or not? Hi. Hello. Nobita. Welcome. I like your icon. Okay, we have a lot of things recognized. Per. Now C and L are two different things, which is not good. Then we have miscellaneous for T. What is happening? Which is an organization. U and oh god, what is happening here? And we even told it to group entities. Oops. It's fine. If it's not hurting anyone, it's fine. Oh yeah, okay. Alright, so it's not answer generation, it's question answering for the other part. What should we do? I'm just gonna take this sentence that I wrote and say, what am I doing? What am I doing? Where am I doing? What am I doing? Let's see. Stream on YouTube. Yep, you're right. Thank you. And the score is 50, so it's not the best, but it's not wrong. Summarization is the task of reducing text into a shorter text while keeping all important parts. I don't know what should we do? Let's go to Wikipedia and A Hitchhiker's Guide to the Galaxy. Get that and ask it to make it smaller. Spelling. That's funny. Alright, let's take this, paste it here. Okay. And ask it to summarize. We can do max length and min length. Okay. And then next is translation. How much more do we have? Oh, it's the last one? Cool. Alright. Okay. Almost done? Not yet. For the translation, this is using something for French and English. I should probably not do that. Oh, okay. Hitchhiker's Guide to the Galaxy is a comedy science fiction series. Originally, I'm curious. Okay, so this part is this part. Okay. Comedy broadcast on Radio 4. It's been adapted to novel, stage show. That's like really good. There's a movie. That's a really good summarization. Nothing about what it's about, which is the last part. This part. Oh no! It doesn't see these two parts. I'm gonna take this away. Okay. Should we try again? I mean, I'm gonna try again because this is truncated a lot more than I wanted it to. We're using Distilbert CNN. Okay, in the meantime, I'm going to go to translation. Translation. Look for something small. What languages does it translate from and to? 5 languages. We have English, French, multilingual. Okay. Nothing about what it's about. Okay, I don't think this is a good summarization, with all due respect. So I'm gonna keep you and do the other one, so that we can check if there's any change between the models. You go, and then you go. Okay, this course is produced by HuggingFace. Yep. Wait, HuggingFace is not... It's not one word? I thought it's one word. Eh? Okay, Google didn't do translation. Why? Should I have told it what to translate from? Because this one says French to English. It's fine. I tried. Oh, other languages? Should we do that? Other languages. Wait. Actually, how do I use it directly from pipeline? Why is there no code? Rude. Yeah, use. There's a blog post that one should go to. Well, I don't wanna. Give me something small. Okay, we have something. What is je? English to ja. What is je? Oh, Chinese. Do you have English to Korean? Because I may be able to read that. Let's look for Helsinki NLP. I'm gonna copy you, go back, paste it here. Oh, there are a lot. I'm gonna search for Korean. Does not exist. Maybe Arabic? What is ID? Oh, that's big. Okay. So if I paste this, English 2. Hey, we found something Korean. But this is all okay. We have one Korean to English, but it's big. So if it takes time, it's my fault because I chose to get it. Okay. So that is this lesson. We just did this one. I'm going to say next, but I don't know how much energy I have left in me. Why does it look this weird? Oh, it looks weird even then. Okay. This is taking its sweet time. We can learn while this is happening. So, I should probably zoom in. That is readable. Oh, this is done. What? 라는 멋진... What's happening here? Oh, it's not English. What's wrong with me? It's French. Of course. Sorry about that. Try again. That was funny. Please take your sweet time. High-level look at the architecture of a transformer model. Here are some reference points in the short history of transformer models. So GPT is the first one. Is the attention is all you need paper about GPT? Is that the output? Then we have BERT. I haven't heard of XLM. Then we have GPT-2. We have this here, XLNet, Roberta, Albert. I haven't heard of T5, BART, Distilbert, Electra, GPT-3, DBERTA, Longformer, M2, M100, and Luke. Luke is a funny name. Alright, let's see. What is PI? I don't know. 인기 있는 기술 여자? What is happening? 지금은 리더입니다. I'm lost. 이거 뭔데? Am I using it wrong? Yeah, from English to Korean. I'm gonna take this, I think I still have it, and try it here and see if it's the model's fault or it's my fault. Yeah? Yeah, no, it's the same thing. 이게 말이 됐냐? I guess this could be produced by, but the other stuff makes no sense. Let's choose something else. What is wrong with this model? 에이즈 잘 있으라 엘? 이거 뭐냐? Is this supposed to be normal? I don't know. Hello. My name is CL. What is wrong? Is this medical? I'm gonna refresh this so that I use the default text just to see if this works. My name is Sarah and I live in London. Okay. 미국 나 플레오에 이해 안수. I have no idea what's happening here. This is supposed to be translation, right? Example 1, example. I'm gonna go. Okay, you know what? So how transformers works can be for later, because if we start here, we probably need to go and learn these 3 things. And because it's been an hour and 14 minutes, I'm not gonna do this one, but I'm not gonna end the stream. I'm gonna look at this one. Introduction to NLP. I probably won't be able to. I don't know. We'll see. I don't think I'll be able to do the whole thing, but let's see.
So the class
If I'm quiet and just watch, I think I might actually. I don't know.
today is Introduction to Natural Language Processing, and I'll be talking a little bit about, what is natural language processing, why we're motivated to do it, and also some of the difficulties that we encounter. And at the end, I'll also be talking about class logistics, so you can ask any logistics questions at that time. So if we talk about what is NLP anyway, does anyone have any opinions about the definition of what natural language processing would be? Oh, one other thing I should mention is I am recording the class. I put the class on YouTube afterwards. I will not take pictures or video of any of you, but if you talk, your voice might come in the background, so just be aware of that. Usually not, it's a directional mic, so I try to repeat the questions after everybody, but for the people who are listening to the recording. So anyway, what is NLP anyway? Does anybody have any ideas about the definition of what NLP might be?
Trying to get computers to understand human language? That's a very broad definition.
Yes. Okay. So the answer was it helps machines understand language better. So to facilitate human and human machine interactions. I think that's very good. It's almost similar to what I have written on my slide here. But in addition to natural language understanding, there's one major other segment of NLP. Does anyone have an idea what that might be?
No. Output?
We often have a dichotomy between two major segments, natural language understanding and natural language generation. Yeah, exactly. So I would say that's almost perfect if you had said understand and generate. So very good. So I say technology to handle human language, usually text using computers, to aid human-machine communication. And this can include things like question answering, dialogue, or generation of code that can be executed with computers. It can also aid human-human communication. And this can include things like machine translation or spell checking or assisted writing. And then a final segment that people might think about a little bit less is analyzing and understanding a language. And this includes things like syntactic analysis, text classification, entity recognition, and linking. And these can be used for various reasons, not necessarily for direct human-machine communication, but also for like aggregating information across large things for scientific studies and other things like that. And I'll give a few examples of this. We now use NLP many times a day, sometimes without even knowing it. So whenever you're typing a doc in Google Docs, there's spell checking and grammar checking going on behind. It's gotten frighteningly good recently, where it checks like most of my mistakes and rarely flags things that are not mistakes. So obviously they have powerful models running behind that. It can do things like answer questions. So I asked ChatGPT, who is the current president of Carnegie Mellon University? And ChatGPT said, I did a quick search for more information. Here's what I found. The current president of Carnegie Mellon University is Farnham Jahanian. He has been serving since July 1st.
Whoa. Who is Farnham Jahanian? That doesn't sound... I'm curious. Carnegie Mellon University president? President? It did sound Iranian. That's really cool. That's very, very cool. Computer scientist. Okay, I'm happy.
Et cetera, et cetera. So as far as I can tell, that's correct. At the same time, I asked how many layers are included in the GPT 3.5 Turbo architecture. And it said to me, GPT 3.5 Turbo, which is an optimized version of GPT 3.5 for faster responses, doesn't have a specific layer architecture like the traditional GPT-3 models. And I don't know if this is true or not, but I'm pretty sure it's not true. I'm pretty sure that, GPT is a model that's much like other models. So it basically just made up this fact.
Hallucination, maybe.
So another thing is NLP can translate text pretty well. So I ran Google Translate on Japanese. This example is a little bit old. It's from a few years ago about COVID, but I retranslated it a few days ago, and it comes up pretty good. You could basically understand what's going on here. It's not perfect, but you can understand the general gist. At the same time, if I put in a relatively low resource language, this is Kurdish.
Why?
It has a number of problems when you try to understand it. And just to give an example, this is talking about some paleontology discovery. It called this person a fossil scientist instead of the kind of obvious English term paleontologist.
Where is the word paleontologist? Well, what is this? I'm so surprised that I see Kurdish here. Is Babardbu supposed to mean paleontologist? Because I have no idea what it means. تویژر و سەرۆکاتی زانای سربەخۆ independent scientist. Babardbu? It's my first time hearing this word.
And it's talking about 3 different T-Rex species, how T-Rex should actually be split into 3 species, where T-Rex has king of ferocious lizards.
I'm still in a bit of shock that I see Kurdish. Translated, right? Translated by Google. Yeah. Wait, no. So this is the normal Kurdish written by a human? Amajan Bokert Kapesa Zorb Nasret. The species Zornia, right? Okay.
Imperator says Emperor of Savage Lizards, and then T. Regina means Queen of Ferocious Snail. I'm pretty sure that's not snail. I'm pretty sure that's lizard. So
Marmilka is, yeah, not snail.
You can see that this is not perfect either.
This is so cool.
Some people might be thinking, why Google Translate and why not GPT? Well, it turns out, according to one of the recent studies we've done, GPT is even worse at these low resource languages, so I use the best thing. Another thing is language analysis can aid scientific inquiry. So this is an example that I've been using for a long time. It's actually from Martin Sapp, another faculty member here, but I have been using it since like before he joined. And this is an example from computational social science answering questions about society given observational data. And their question was, do movie scripts portray female or male characters with more power or agency in movie script films? So it's asking kind of a societal question by using NLP technology. And the way they did it is they basically analyzed text, trying to find the agents and patients in a particular text, which are the things that are doing things and the things that things are being done to. And you can see that essentially male characters in these movie scripts were given more power and agency, and female characters were given less power and agency. And they were able to do this because they had NLP technology that analyzed and extracted useful data and turned it into a very easy form to do kind of analysis of the variety that they want. So I think that's a major use case of NLP technology that does language analysis nowadays. Turn it into a form that allows you to very quickly do aggregate queries and other things like this. But at the same time, language analysis tools fail at very basic tasks. So these are some things that I ran through a named entity recognizer. And these were kind of very nice named entity recognizers that a lot of people were using. For example, Stanford Core NLP and Spacey. And both of them, I just threw in the first thing that I found on the New York Times at the time. And it basically made at least one mistake in the first sentence. And here it recognized Baton Rouge.
I was literally just testing it on HuggingFace, and it assumed my name is supposed to be an organization. So, yeah. And I wrote HuggingFace as in one word, and it separated it, but in a wrong way.
And here it recognized Hurricane Ida as an organization. So, like even these things that we expect should work pretty well make pretty silly mistakes. So in the class, basically what I want to cover is what goes into building state-of-the-art NLP systems that work really well on a wide variety of tasks. Where do current systems fail? And how can we make appropriate improvements and achieve whatever we want to do with NLP? And this set of questions that I'm asking here is exactly the same as the set of questions that I was asking 2 years ago before ChatGPT.
Okay.
I still think they're important questions, but I think the answers to these questions is very different. And because of that, we're updating
especially the first one, and Canally, the Turing test
materials to try to cover, the answers to these questions in kind of the era of large language models and other things like that. So that's all I have for the intro. Maybe pretty straightforward. Are there any questions or comments so far? If not, I'll just go on. Okay, great. So I want to first go into a very high-level overview of NLP system building. And most of the stuff that I want to do today is to set the stage for what I'm going to be talking about in more detail over the rest of the class.
Okay.
And we could think of NLP systems through this kind of general framework where we want to create a function to map an input X into an output Y, where X and or Y involve language. And do some people have favorite NLP tasks or NLP tasks that you want to be handling in some way? Or maybe what do you think are the most popular or important NLP tasks nowadays?
I mean, LLM's language generation is like the most talked about one, or like question answering, summarization stuff that you interact with the model. But most used would probably be different, like spell checking.
Okay, so translation is maybe easy. What's the input and output of translation?
Input is text. Output is also text, but in another language.
Okay, yeah, so in translation, input's text in one language, output is text in another language. And then what is a good translation?
That makes sense.
Yeah, correct or the same is the input, basically, yes. It also should be fluent, but I agree. Any other things? Generation, the reason why I said it's tough is it's pretty broad, and it's not like we could be doing generation with lots of different inputs, but yeah, any other things, maybe a little bit different? Yeah. A scenario and a multiple choice question about the scenario. And so what would
question
the
answering
in the multiple choice question are probably the input, and then the output is an answer to the multiple choice question. And then there it's kind of obvious, like what is good, it's the correct answer, sure. But interestingly, I think a lot of LLM evaluation is done on these multiple choice questions, but I'm yet to encounter an actual application that cares about multiple choice question answering. So there's kind of a funny disconnect there, but yeah, I saw a hand in the back. Yeah, vector search. That's very good. So the input is
a vector.
Okay, yeah, so I'd say the input there is a query and a document base. And then the output is maybe an index into the document or something else like that, sure. And then something that's good. Here's a good question. What's a good result from that? What's a good output? Yeah, exactly. So that just to repeat, it's like we need to have a good similarity metric. We need to have a good threshold where we get like the ones we want and we don't get the ones we don't want. And we're going to talk more about that in the retrieval lecture, exactly how we evaluate and stuff. But yeah, good. So this is a good, here are some good examples. I have some examples of my own. The first one is kind of the very generic one, maybe kind of like generation here, but text and continuing text. So this is language modeling. So you have a text and then you have the continuation. You want to predict the continuation. Text in another language is translation. Text in a label could be text classification.
Right.
Text in linguistic structure or some kind of entities or something like that could be language analysis or information extraction. We could also have the image in text.
Yay! Audio transcription and image captioning are also stuff that NLP does.
Which is image captioning. Or speech and text, which is speech recognition. And I take the very broad view of natural language processing, which is if it's any variety of language, if you're handling language in some way, it's natural language processing. It doesn't necessarily have to be text input, text output. So that's relevant for the projects that you're thinking about too at the end of this course. So the most common FAQ for this course is, does my project count? And if you're uncertain, you should ask, but usually like if it has some sort of language involved, then I'll usually say yes, it does count. So if it's like code to code, code is not natural language. It is language, but it's not natural language. So that might be borderline.
It's artificial language, but like even code is considered an NLP thing because ChatGPT can help you. I guess in a way, like if you ask it to explain your code, then that's obviously natural human language.
We might have to discuss about that. Cool. So next I'd like to talk about methods for creating NLP systems.
Okay.
And there's a lot of different ways to create NLP systems. All of these are alive and well in 2024. The first one is rule-based system creation.
Yay.
And so the way this works is, like, let's say you want to build a text classifier. You just write the simple Python function that classifies things into sports or other. And the way it classifies it into sports or other is it checks whether baseball, soccer, football, and tennis are included in the document and classifies it into sports. If so, other if not. So has anyone written something like this? Maybe not a text
Probably.
classifier, but you know, to identify entities or split words or
Anything in regular expression is basically that.
something like that. Has anybody not ever written anything like this?
Oh.
Yeah, that's what I thought. So
that's what I thought.
Rule-based systems are very convenient when you don't really care about how good your system is, or you're doing something that's really, really simple, and it'll be perfect even if you do the very simple thing. And so I think it's worth talking a little bit about them, and I'll talk a little bit about that this time. The second thing, which very rapidly over the course of maybe 3 years or so has become actually maybe the dominant paradigm in NLP, is prompting, and prompting a language model. And the way this works is you ask the language model, if the following sentence is about sports, reply sports, otherwise reply other. And you feed it to your favorite LM. Usually that's GPT something or other. Sometimes it's an open source model of some variety. And then it will give you the answer. And then finally, fine tuning. So you take some paired data and you do machine learning from paired data where you have something like, I love to play baseball. The stock price is going up. He got a hat trick yesterday. He is wearing tennis shoes. And you assign all these labels to them, train a model. And you can even start out with a prompting-based model and fine-tune a language model. So one major consideration when you're building systems like this is the data requirements for building such a system.
Right.
And for rules or prompting where it's just based on intuition, really no data is needed whatsoever. You don't need a single example, and you can start writing rules. Or just to give an example, the rules and prompts I wrote here, I didn't look at any examples, and I just flipped.
Even if it's some sort of grammar related thing, you can say if like you see A in front of a text, then that's singular. If you see S at the end, that's plural. Even if the output is wrong, at least it's rules, you know? So you don't need to have a lot of data.
So this is something that you can start out with. The problem is you also have no idea how well it works if you don't have any data whatsoever, right? So you might be in trouble if you think something should be working. So normally the next thing that people move to nowadays when they're building practical systems is rules or prompting based on spot checks. So that basically means that you start out with a rule-based system or a prompting-based system, and then you go in and you run it on some data that you're interested in. You just kind of qualitatively look at the data and say, oh, it's messing up here. Then you go in and fix your prompt a little bit, or you go in and fix your rules a little bit, or something like that. So this is kind of the second level of difficulty. So the third level of difficulty would be something like rules or prompting with rigorous evaluation. And so here you would create a development set with inputs and outputs. So you create maybe 200 to 2,000 examples, and then evaluate your actual accuracy. So you need an evaluation metric, you need other things like this. This is the next level of difficulty, but if you're going to be a serious, NLP engineer or something like this, you probably will be doing this a lot, I feel. And then, so here now you start needing a dev set and a test set. And then finally, fine-tuning, you need an additional training set. This will generally be a lot bigger than 200 to 2,000.
Isn't it evaluation, test, and train? I mean, who am I to correct him? Sorry, apologies. I agree, it's dev test. I really like him.
Examples. And generally the rule is that every time you double,
it gets half.
Every time you double your training set size, you get about a constant improvement. So if you start out down here with zero-shot accuracy with a language model, you create a small training set and you get, a pretty big increase. And then every time you double it, it increases by a constant factor. It's kind of like just in general in machine learning, this is a trend that we tend to see. So, so based on this, there's kind of like you get a big gain from having a little bit of training data, but the gains very quickly drop off, and you start spending a lot of time annotating.
Cool.
So yeah, this is the general overview of the different types of system building. Any questions about this or comments or things like this? I think one thing that's changed really drastically from the last time I taught this class is the fact that number 1 and number 2 are the things that people are actually doing in practice, which was, people who actually care about systems are doing number 1 and number 2 as the main thing. It used to be that if you were actually serious about building a system, you really needed to do the fine tuning. And
Oh my God. Sorry, I got distracted about what's coming. Oh, so cool. Oh my God. This is really cool.
Yeah. Mm-hmm. So it's definitely an empirical observation. In terms of the theoretical background, I can't immediately point to a particular paper that does that, but I think if you think about I think I have seen that they do exist in the past, but I can't think of it right now. I can try to come up with an example of that.
Oh, sorry.
So, yeah, I should take notes.
What did I do?
Or if someone wants to share one on Piazza, if you have any ideas and want to share on Piazza, I'm sure that would be great. It'd be great to have a discussion on Piazza. Performance increase. Cool. Okay. So next, I want to try to make a rule-based system. And I'm going to make a rule-based system for sentiment analysis. And this is a bad idea. I would not encourage you to ever do this in real life.
Do I continue? I really want to continue. Should I continue? I'm rather late. Let me check some things. How long does it take? Maybe I will stop when the practical part starts. Or maybe I'll stop when the practical part ends. Let's see, because this looks really interesting.
But I want to do it here to show you why it's a bad idea and like what are some of the hard problems that you encounter when trying to create a system based on rules. And then we'll move into building a machine learning-based system after we finish this. So if we look at the example task, this is review sentiment analysis. It's one of the most valuable tasks that people do in NLP nowadays because it allows people to know how customers are thinking about products, improve their product development and other things like that, and people's satisfaction with their social media services and things like this. So basically, the way it works is you have outputs, or you have sentences, inputs, like I hate this movie, I love this movie, I saw this movie, and this gets mapped into positive, neutral, or negative. So I hate this movie would be negative, I love this movie positive, and I saw this movie is neutral. So that's the task: input, text, output, labels, ternary sentence label. And in order to do this, we would like to build a model. And we're going to build a model in a rule-based way, but we'll still call it a model. And the way it works is we do feature extraction. So we extract the salient features for making the decision about what to output next. We do score calculation, calculate a score for one or more possibilities. And we have a decision function. So we choose one of those several possibilities. And so for feature extraction, formally what this looks like is we have some function, and it extracts a feature vector. For score calculation, we calculate the scores based on either binary classification, where we have a weight vector, and we take the dot product with our feature vector, or we have multi-class classification, where we have a weight matrix, and we take the product with the vector, and that gives us, scores.
How is this rule-based? Let's see.
Over multiple classes. And then we have a decision rule. So this decision rule tells us what the output is going to be. Does anyone know what a typical decision rule is? It's maybe so obvious that you don't think about it.
Output?
A threshold. So like would that be for a single binary scalar score or a multiple ones? Binary, yeah. So, and then you would pick a threshold, and if it's over the threshold, you say yes, and if it's under the threshold, you say no. Another option would be you have a threshold, and you say yes, no, if it's under the threshold, abstain. So you don't give an answer. And depending on how you're evaluated, what is a good classifier, you might want to abstain some of the time also.
Okay.
For multi-class, what's a standard decision rule for multi-class? Argmax, yeah, exactly. So basically you find the index that has the highest score in the output. We're going to be talking about other decision rules also, like self-consistency and minimum base risk later for text generation. So you can just keep that in mind, and then we'll forget about it for like several classes.
Okay.
So for sentiment classification, I have a code walk here. And
code walk.
This is pretty simple, but if you're bored of the class and would like to try out yourself, you can challenge and try to get a better score than I do over the next few minutes.
Oh, that's
but we have this
cool.
rule-based
Oh my
classifier in here.
god.
And
I will say he's a really, really, really cool professor. If you're bored of the class, try to make it better. Like, how cool is that?
I will open it up in my VS Code to try to create a rule-based classifier. And basically the way this works is that we have feature extraction. We have feature extraction, we have scoring, and we have decision rule. So here for our feature extraction, I have created a list of good words and a list of bad words.
Okay.
And what we do is we just count the number of good words that appeared and count the number of bad words that appeared. Then we also have a bias feature. So the bias feature is...
So the rule-based part is that everything is basically static. We have a list, and if it's here, good. If
a feature that's always 1. So what that results in is we have a dimension 3 feature vector, where this is like the number of good words, this is the number...
Are they all like same level of good and bad? And how many good words there are, you give it a plus. How many bad words, you give it a plus for bad. And then at the end, you count it based on that weight.
For bad words, and then we have the bias. And then I also define the feature weights. So for every good word, we add 1 to our score. For every bad word, we subtract 1 from our score, and for the bias, we absorb it. And so we then take the dot product between...
Honestly, that's a pretty good model.
These two, and we get minus 0.5.
Hard to maintain.
And that gives us the score.
But fun.
So let's run that. And I read in some data. And what this data looks like is basically we have a review, which says The Rock is destined to be the 21st century's new Conan, and that he's going to make a splash even greater than Arnold Schwarzenegger, Jean-Claude Van Damme, or Steven Seagal. So this seems pretty positive, right?
Definitely positive, but I saw the name Steven Seagal and I was like, I did a double take.
That's a pretty high order to be better than Arnold Schwarzenegger or Jean-Claude Van Damme, if you're familiar with action movies. And so, of course, this gets a positive label.
I didn't see Chuck Norris.
And so we have run classifier. Actually, maybe I should call this decision rule, because this is essentially our decision rule. And here, I basically do the thing that I mentioned here, the yes, no, abstain, or in this case, positive, negative, neutral. So if the score is greater than 0, we return 1. If the score is less than 0, we return -1, which is negative. And otherwise, we return 0. We have an accuracy calculation function just calculating the outputs are good.
Cool.
And this is the overall label count in the output. So you can see there's slightly more positives than there are negatives. And then we can run this, and we get a score of 43.
Okay.
And so one thing that I have found
that was a bad score.
I do a lot of kind of research on how to make NLP systems better. And one of the things I found really invaluable is if you're in a situation where you have a set task and you just want to make the system better on the set task, doing comprehensive error analysis and understanding where your system is failing is one of the best ways to do that. And I would like to do a very rudimentary version of this here. And what I'm doing essentially is I'm just randomly picking several examples that were correct. And so like let's look at the examples here. Here the true label is 0, in this predicted 1. It may not be as cutting, as witty, or as true as back in the glory days of Weekend and 2 or 3 things that I know about her. But who else engaged in filmmaking today is so cognizant of the cultural and moral issues involved in the process? So what words in here are a good indication that this is a neutral sentence? Any ideas? little bit tough, huh? We're starting to think maybe we should be using machine learning. Even by the intentionally low standards of frat boy humor, sonority boys is a Bowser. I think frat boy is maybe negative sentiment if you're familiar with US. I don't have any negative sentiment, but the people who say it that way have negative sentiment maybe. So
Yes.
if we wanted to go in and do that, we could maybe, I won't save this, but
Yeah.
I'll go back and fix it. Crass. Crass is pretty obviously negative, right? So I can add crass.
Okay.
Actually, let me just add crass. And then I'll go back and have our training accuracy. Maybe I need to run the whole thing again. And that budged the training accuracy a little, the dev test accuracy not very much. So I could go through and do this. Let me add unengaging. So I could go through and do this all day, and you'd probably be very bored.
Yep.
Unengaging. But I won't do that because we have much more important things to be doing. So anyway, we could go through and design all of the features here. But like, why is this complicated? Like, the reason why.
Because you have to update it each time.
Why it was complicated became pretty clear from the very beginning. The very first example I showed you, which was
you cannot keep up with, slang.
That was a really complicated sentence. Like, all of us could see that it wasn't like really strongly positive. It wasn't really strongly negative. It was kind of like in the middle. But it was in the middle, and it said it in a very long way. Not using any clearly positive sentiment words, not using any clearly negative sentiment words. So, yeah, basically, I improved. But what are the difficult cases that we saw here? So the first one is low frequency words.
Thing.
So here's an example. The action switches between past and present, but the material link is too tenuous to anchor the emotional connections that purport to span a 125-year divide.
What?
So this is negative. Tenuous is kind of a negative word. Purport is kind of a negative word, but it doesn't appear very frequently. So I would need to spend all my time looking for these words and trying to add them in. Here's yet another horse franchise mucking up its storyline with glitches. Casual fans could correct in their sleep. Negative again. So the solutions here are keep working until we get all of them, which is maybe not super fun. Or incorporate external resources such as sentiment dictionaries that people created. We could do that, but that's a lot of engineering effort to make something work. Another one is conjugation. So we saw unengaging, I guess. That's an example of conjugation. Some other ones are operatic sprawling picture that's entertainingly acted, magnificently shot, and gripping enough to sustain most of its 170-minute length. So here we have magnificently. So even if I added magnificent, this wouldn't have been caught, right? It's basically an overlong episode of Tales from the Crypt. So that's maybe another example. So some things that we could do, or what we would have done before the modern paradigm of machine learning, is we would run some sort of normalizer, like a stemmer or other things like this, in order to convert this into the root words that we already have seen somewhere in our data or have already handled. So that requires conjugation analysis or morphological analysis, as we say it in technical. Negation. This is a tricky one. So this one's not nearly as dreadful as expected.
That's
so
positive.
Dreadful is a pretty bad word, right? But not nearly as dreadful as expected is like a solidly neutral,
Yeah.
Or maybe even positive.
Rather positive.
I would say that's neutral, but neutral or positive, it's definitely not negative. Serving Sarah doesn't serve up a whole lot of laughs. So laughs is obviously positive, but not serving up laughs is
negative.
Negative. So if negation modifies the word disregard it, now we would probably need to do some sort of syntactic analysis or semantic analysis of some variety. Metaphor and analogy. So puts a human face on a land most Westerners are unfamiliar with. This is positive.
Yeah.
Green might want to hang on to that ski mask, as robbery may be the only way to pay for this next project. So this is saying that the movie was so bad that the director will have to rob people in order to get money for the next project. So that's kind of bad, I guess. Has all the depth of a wading pool. This is kind of my favorite one because it's really short and sweet, but you need to know how deep a wading pool is.
I don't know.
So that's negative. So the solution here, I don't really even know how to handle this with a rule-based system. I have no idea how we would possibly do this. yeah, machine learning-based models seem to be pretty adaptive. Okay, and then I start doing these ones. Anyone have a good idea?
No.
Any other friends?
I'm thinking neutral.
No? Okay. So yeah, that's positive. That one's negative. And the solution here is learn Japanese, I guess. Or whatever other language you want to process. So like obviously rule-based systems don't scale very well. So we've moved, but like rule-based systems don't scale very well. We're not going to be using them for most of the things we do in this class. But I do think it's sometimes useful to try to create one for your task, maybe right at the very beginning of a project, because it gives you an idea about what's really hard about the task in some cases. So yeah, I wouldn't entirely discount them. I'm not introducing them for no reason whatsoever.
That's it. I'm gonna stop here and 100% subscribe to his channel because oh my god, this is just like alive. You know, I love Jeremy Howard's, and like I put them next to each other with their ability to teach. Because like something as dry as a lectures are supposed to put you to sleep. To be this interesting and entertaining, I am in love with the knowledge and the way that he's teaching. That's really cool. All right, so I think that's it for today, right? Let's recap. We went to Hugging Face, learning, and we went to the NLP course, even though there are other courses, but that's where we are. And we did 1, 2, 3. Then we went to YouTube and went to this Carnegie Mellon University Advanced NLP Spring 2024. And there's a new video apparently. And we watched half of the video shared by Graham Newbig. Okay. I'm going to check his GitHub because he had this code on GitHub. GitHub. I need to search GitHub. GitHub. 2024. He had it as a link. Wait, let me see if it's part of this here. Course details. Content. Lectures. Okay. Code. There we go. Found it. It's called a NLP code. Right. We found it. Good, good. So that exists. We have slides. We have even extra reading material. How can you not fall in love with a teacher that gives you everything? Still, I'm going to pause on this slide and be like, oh my god, I am just surprised. Anyway, fun. That's it for today. I will probably continue tomorrow. Thanks for those joining me online. You can follow me along by learning NLP and ML and all of this fun stuff, trying to wrap our heads around the new technological advances of the world. Thanks for stopping by. I am still surprised that my YouTube channel has 1,000 subscribers. Why? Appreciate the love on Twitch and on YouTube. Hope to see you again tomorrow if all goes well. Thanks for stopping by, and I'm going to end the stream starting 5. If you have anything to say, go ahead. Otherwise, thanks again. 4, 3, 2, 1. Goodbye. Thank you.